Hi, and I'd like to welcome you to this session where we'll be talking about trustworthy Internet of Things. I am Arjuman Samuel. I work for the Azure Internet of Things team. I lead the security and privacy efforts there. And today I'm going to walk you through our thinking about what we mean by trustworthiness of IoT. We believe that security is one very important aspect of making IoT trustworthy, but there are others as well. And so today I'm going to actually talk you through all of that. I usually like to open my security conversation with a few scary stories, right? Security is not really fun without those scary stories. So before I go there, I'm hoping that we all are comfortable with the term IoT, Internet of Things. We all understand what that entails. It means sensor devices and the cyber world and the physical world coming together, and because that's what IoT is. It is beyond cybersecurity. Cybersecurity has been beaten to death, I believe, but still has a huge number of issues that we need to think about. But this is cyber physical together. This is physical devices and sensors coming together to form networks. So that's just the preamble there, and here is my first scary story. And this is from a report by the Department of Homeland Security. This probably is 2 years or a year and a half back, where they looked at these two hacks on our critical infrastructure in this country. The one on your left is about malicious actors taking over the control systems of a highway, right? And they were able to control lights, and they were able to control a bunch of things, and then they were not satisfied with that. They were able to also put this thing up on the display so that everybody would know that they have taken over. So no harm really was done, but the point is it unearthed how vulnerable our infrastructure is. And interestingly, when they went back and they did an analysis of how did anybody get into the system, actually it was pretty simple. As I'm sure you all can imagine, I'm assuming we all have security backgrounds, so we all can imagine. And the first thing that comes to your mind exactly happened here, right? So the machine, the whole control system was bought like 5-10 years back. There was a little port, RJ45 port, network. Nobody bothered to connect that. The system was working. It was, within the confines of their operation. And some wise guy found a network cable, connected RJ45 on the two ends, and said, oh yeah, great, and now I have an interface, this interface available outside the network as well, right? And this person did not think through the security implications of doing that. And not just that, this person also did not bother to change the default admin password, which happened to be blank. Admin blank, go in. And then somebody, these other malicious actors, they started they do that all the time, right? IPs and ports, and see if port 80 has something alive on it, just for fun. I would do that at times. And then up comes a UI, a user experience, which says, enter your username password. Welcome to whatever, the highway blah system of the city. And so this person said, okay, let me try the few dictionary password attacks, and bingo. That brings to the surface some very important things that are happening with this IoT today. And I'm going to go into those details. Why did this happen? Why was the person who was responsible for this equipment not thinking through the whole end-to-end security model? Similar is this is the one on your right. This is a water treatment plant in the city of South Houston. Again, similar things. Somebody just connected it without thinking what would go on, and the malicious actors had access to everything that the waste treatment plant does. So they could actually pump up the chlorine level in water. or reduce it. And they could do a bunch of malicious things. They did not, luckily, but they could do that. All they did was they took screenshots of the user experience that was available to them and started posting them on Twitter. So the attack was, while it was happening, was playing out on Twitter. And luckily, the administrators, because it was hashtag South Houston, they picked up and then they started, doing things about it. So these are just two examples of how vulnerable physical infrastructure is, critical infrastructure, right? The same could happen to our smart power grids. The same could happen to our hospitals. They're all trying to connect everything together. IoT is this new, shiny thing that everybody wants to do, and without due diligence of security. So that's my scary story here. I have many more. After this, if you want, we can talk about those. And then I have a theory. And this has been shared with a number of people who work in this field. We have a theory. There are two worlds that exist in this IoT security thing. It's almost like two different planets, right? There is one which is on the left, which is very well understood by many, which we call information technology, or IT. So people who do IT security are now, part of this whole game, because they are charged with the networks, the apps, the security of that end of the house. And then there are these people who live on another planet, literally. They are the people who manage these machines, right? They are the people who we call operational technology, people who manage these, buy them, install them, and keep them all working. And they live on different planets. What do I mean they live on different planets? Well, IT, as we all again know, defines threats in a certain way, define mitigations in a certain way. They look at what is happening in that whole infrastructure of networks, apps, databases, cloud, all of those things, and systems and devices, which are computers and laptops. They look at it in the IT sense. They have a set of tools. If you're developing software for your infrastructure, an IT guy would say secure software development lifecycle, right? You want to do threat modeling. You want to do run some tools. You want to look for buffer overflows. You want to do all of those things so that your IT infrastructure becomes secure, right? And we have been doing it for 20, 30 years now, and we understand that very well. On the other hand, operational technology folks who are responsible for these physical devices, machines, for them, their whole reason for existence has nothing to do with security. Their reason for existence is safety. The machine should not kill anybody. The robotic arm should not, the robotic arm or the device should not be harmful to the environment. Nobody should come in and start playing around with the machine. So put it in a secure location. Place a guard outside, a security guard outside. That's what they think about. That's what they live for. Security is not top of mind. Safety is. In addition to that, they also think about reliability, right? All day long, when they deploy these machines, they're thinking about reliability. And they're huge. So in the last few years, it's not that OT has not been exposed to software. They have been, right? Many of these machines have controllers on them. They have these CAN bus and Modbus protocols, and then they have these little controllers where they go in and control these devices. So they have been exposed to software, but then in most cases, they were in a sandbox. Their whole control system worked only in that environment. So air gap between the outside world and them. And now what is happening is we are bringing these two worlds together, right? We are bringing IT, which runs these networks and it knows how to scale up apps and databases and systems and all of those things, and then we are bringing in these hardware device specialists. And based on our experience working with a bunch of different companies, interestingly, they don't even talk the same language, right? They don't even understand the same threats. They don't even understand how these two worlds can come together and work together. So the promise of IoT is actually creating this system of systems, but the people who own these systems and who manage them and deploy them are unfortunately not on the same page. So that creates a huge disconnect when you start talking about securing and making IoT trustworthy. So some of the reasons, in addition to all of that, I'll go very briefly over each of these. Some of the reasons are over here. The top one is interesting. Even an IT guy would say, seriously, you had a server which cost $5,000, and I had it in a data center, and which was all protected, and the network all protected, and I could deploy whatever I wanted, so I had the tools. And for the last 20 years, we are still struggling to secure it, right? And now what you have is a $20 device deployed out in the wild with no physical security, with no cyber security, and now you want me to secure that, right? So the pressure is these low power, low resource devices on which even adding secure storage is a boardroom discussion, right? There's a $20 device on which you want to add a 50-cent TPM to secure keys, and the cost of manufacturing and all of that would go up. And so it's a boardroom discussion, should we add that or not? Because it's a $20 device. With a $5,000 server, it was a no-brainer. But now that has become important discussion. So you also have unattended devices. You have these devices which are IoT devices, small little sensors or actuators which are deployed on roads, deployed in malls, deployed all over the place. And so how do you secure them, because now they are unattended? Many times these devices may just be in the user's preview. They are not managed centrally because they are distributed. Network connectivity is good and bad, because now these devices are alive on the network all the time. And so you can actually access them, you can do funny things like we discussed. Mobility. So expectation from many of these devices, such as cars and other IoT devices like aeroplanes, are mobile. They move around, right? And the complexity of securing them becomes much more a problem. I'll give you an example. So even the laws that govern the security and safety of these devices change during the life cycle of the device. An aircraft takes off from this country, goes to China, and then comes back. During that one trip, it crossed 2-3 different regulatory regimes. It could upload data somewhere and not upload data somewhere, and had to do different things with the profile of the device. So it's hard. And we talked about the last one. And then, of course, when we talk about industrial IoT, then we also need to understand that a bunch of these devices have been around for a long time, right? Brownfield. We have these machines, and nobody is going to throw away those machines. These are trillions of dollars total worth of machines deployed out there, and now they are being connected. They were never designed to be secure. They were never designed to be part of a larger network of machines, right? So when we talk to our partners who are looking for deploying IoT in these environments, the first thing comes, oh, by the way, I have an investment of a few $1 million which was made 20 years back. The machine is still good. If I replace it today, that's like same millions of dollars multiplied by 1.3 or 1.4. So I can't do that right now. How do I secure? But I want all the benefits of IoT from that. So it's an interesting conversation there. Yep. Okay, so the way we look at IoT is to talk about it holistically. Right? Security is one, and we'll go into more detail about security. But I would just argue that if you are thinking about deploying IoT, working with your partners, or deploying IoT in-house for your own business processes or transformation, think about it holistically. Think about not just security, not just privacy, think about the reliability and safety of those machines, because the pressure of threats, which is these environmental threats, malicious threats, human errors, system faults, they all are going to be together on the system. You just can't secure the system and perhaps make it private, but not think about safety and reliability. So that's how we look at trustworthy IoT. Now, we have a bunch of different options, different products which help you go towards a trustworthy IoT, essentially security aspect of it. By the way, I won't cover safety now because safety is in the preview of people who actually manage devices. I'm going to concentrate more on security and what IoT security would mean. So within our Microsoft offering, we have a bunch of different things that products that we offer. I'm going to first talk about the client side, one of the client side options, and then I'm going to talk about the cloud side, and then I'm going to start talking about what can be done in all of that and how we believe end-to-end you can secure IoT. So the first thing to consider here is that Windows 10 IoT is an operating system which is a derivation or a SKU within Windows 10 family of operating systems, which you can deploy on IoT devices, right? What does it give you? One, it is designed with the developer in mind, with the user experience in mind, and so it allows you to be productive with the system. It's also commercial, so hence it is tested and it's gone through all of those processes. It is also trusted because it has all the ability to secure, to do secure storage. If you want to secure your device with keys, it has a TPM chip on it, and so on. So it has been end-to-end secured in that way. And of course, you can have a connected infrastructure built around it because out of box it supports a bunch of protocols which you could use. And all of this, of course, is to deploy a device. Now, when you think about a device is not just one device. A device could be a small device or a large device, a big device with more processing. So we have these three different layers of IoT core, of Windows 10 IoT. The bottom tier over here is called the IoT core. This usually would go on a device which does not have a user experience of its own. An IP camera would be one example, right? So it's small footprint, you put it on a device, and then it just works. The next level would be an IoT mobile, Windows 10 IoT mobile, which essentially you can put on barcode scanners and devices which have a little bit more power, but also can surface some kind of user experience. And then, of course, the Windows 10 IoT Enterprise, the top layer, which is a powerful machine which actually you can deploy on a jet engine, a robotic arm where you require that kind of power. So these are all the different SKUs of Windows 10 IoT. Now, we have built this platform, the Windows 10 platform, with security in mind. So the most important thing is when you want to secure a device, you want to have some kind of secure storage on the device. So TPM 2.0 is a standard which is pretty recent. It is deployed in probably all of the laptops you are using right now to secure them. So Windows 10 IoT also supports using TPM. And then, of course, on top of it, we have an API layer which allows you to access all functionality of TPMs. Now, TPMs is not just for storage. TPM is also when you put a key in there and you want to, for example, calculate a hash based on that key, all of that processing happens in that hardware. So it is not discoverable. You can't attach a debugger to that hardware and discover the keys. So it's built to be secure not just in storage but also in processing. And to access all of that, there's an API layer on top of it. And to make it easy for developers to use it, we have a TPM simulator as well. And then, of course, moving up the stack. So this was about the client side, and the client side secured with Windows 10. Moving up the stack in the cloud, we have the Azure IoT, which is hosted in Microsoft Azure. Now, this cloud infrastructure, which I'm sure you have heard quite a lot yesterday, today, and will continue hearing about it, is built with security as the core foundation of this infrastructure, right? While it is big, it's one of the largest online compute storage platform out there. It is also secured by a bunch of different functions or bunch of different things that are happening. We have constant monitoring of this huge infrastructure deployed around the world. It's not one data center, it's 30-some data centers around the world. And so we have a digital crime unit, we have a security response center, we have malware protection. So we have all of those built as part of our infrastructure, which we call Azure. And then on top of it, as a service, we offer what we call Azure IoT Suite. Now, I'll just go over into the story of what this suite is. If some of you came to my yesterday's talk, you probably heard about it, so I'll keep it very short. This really is a way to connect devices, IoT devices, to the cloud, to collect data from those devices, and use this whole pipeline of insights that is available in the cloud. Now, what does that mean? You have data coming in from devices, you want to run machine learning on the data, right? So that happens in the cloud. You have a large number of devices pumping large amount of data to the cloud, and now you can run machine learning. You can run stream analytics. So within a window, when the data is coming in, you can actually analyze what's going on, and you can do something about it. So essentially, it is a bunch of pre-configured solutions. So starting from the device all the way to the cloud, in the cloud we have all this pipeline of insights, machine learning, storage, stream analytics, to visualization, so Power BI to visualize. We built that whole pipeline for some scenarios which we believe are common. And the common ones are remote monitoring and predictive maintenance. And then we took this whole pipeline, these two solutions, we packaged it up, we open sourced it in source form and put it on GitHub. Right? So what does that mean? That means that if you want to start with this pre-configured solution of remote monitoring, if you have a scenario where you're remotely monitoring your devices, you simply deploy that today. We'll do all the plumbing that is required, and then when you want to adapt it, you simply get the source code, you start adapting it to your needs. Obviously, it will be slightly different than what is in there, and then now what you have is a IoT end-to-end solution which is for you, which is adapted exactly for your scenario over a period of time. And you could add stuff to it, you could take things off, but source code is there and you could play around with it. Now also on the device side, so here is the whole pipeline, right? So on your left you have the device, and then the connectivity, and then the cloud, and then backend systems. So I'll just go over it from the left to right. On the left side is your devices. You could put Windows IoT Core on it. You could also put any operating system on it. It could be Linux, it could be RTOS, it could be a single file operating system in MCUs, Arduino type operating systems, or hardware which run single executables. It could be that. We have libraries in multiple languages, all of them open sourced, put on GitHub, which you can get from there. If your device runs a CPU, has a battery, and runs network, you could be connected to IoT, Azure IoT, right? You bring in the C library, you bring in the Java library, you bring in that Node.js library, or you bring in the Java or Python library, you deploy it on your device, and your device is now connected to the cloud. All of those libraries open sourced in GitHub. So that's the left side. So any device can connect, and then the cloud itself provides you with analytics, it provides you with a bunch of management activities like device registry, authentication, authorization, etc. And then the key here is that this whole system should not exist in a vacuum, right? It should not exist only as an IoT solution bringing in data into the cloud. It should also exist with your existing backend systems. So there's an API layer towards the end, which can be connected to your SAP or Oracle or DB2 or whatever, right? And you can call in, it's a REST call that you make to that API layer, and you could bring in that device data, or an aggregation of the device data, or analytics from that device data, or alerts from that device data into your backend systems. And that kind of closes the loop, right? You have the devices deployed in your environment, you have this whole cloud, analytics in the cloud, storage in the cloud, alerting, all of those in the cloud, and now those can be brought into your existing production planning and control, CRM systems, sales systems, what have you, to augment all of that flow with more data from the devices, right? So that really is an overview, a kind of a high-level view of what we offer as a product. Now let's talk about some of the security implications of doing that, right? So the first thing here is the device, and then the connection security, and then the cloud security. So in terms of the connection security, we have authentication and authorization for the device. The device does mutual authentication between itself and the cloud service. Mutual authentication means the device presents a certificate, X509 certificate, to the service presents a certificate to the device, mutually they authenticate each other, and only then you can pass data from the device to the cloud. And vice versa, you can pass data from the cloud to the device for some commands. And then we have authorization on top of the device. So in the portal, you can define authorization that this device should not be able to write to this part of my solution. You can define those policies in the cloud. You can also go back and you can say that I think this device is compromised. So in the cloud, you could revoke the device, and its certificate would be revoked, and now that device cannot connect to your cloud. Right? So there's a lot of control you have in the cloud and in this whole infrastructure to control your device and control the security of your device. And then, of course, the connection security, we ensure confidentiality and integrity through encryption and authentication through X509 certificates for the TLS-based communication. And then when you come to the cloud, there are a bunch of technologies that we have there which you can use to secure your data, secure your apps, and secure your actions. And some of them are listed here. I'll just pick out this Azure Active Directory. It gives you an RBAC model, role-based access control model, to group users together, to define permissions on users, and define permissions on who has access to what. So that's really our top-level security profile of how this whole IoT solution works. Now, we also believe that just putting those different things in different places, those security safeguards, is not sufficient, right? What if, and these are what ifs, right? But they are real what ifs. What if your channel is secure, but your device was manufactured in a way where it is not secure? You do not control that device, right? You do not control the device. You're not involved in the manufacturing of the device. It's probably off the shelf. The operating on the operating system on the device is probably not even known to you. It could be a boutique Linux and unknown to you. So how do you actually start protecting these devices? And then, of course, the cloud and data and all of that. So our point of view there is that securing IoT is an end-to-end game. We have to think about defense in depth, right? I, as the owner of Azure IoT, can guarantee you that anything in the cloud, we have Azure and multiple layers of security on top of Azure. But unless you think end-to-end, from the hardware silicon to the operating system that exists on that silicon in the wild, to how you authenticate, to how you secure your keys, to how it communicates over networks, you have to think end-to-end. And that is why our key thinking here is defense in depth. You have to deploy multiple levels and layers of defense on your IoT infrastructure, right? So as I like to say, attacks on IoT infrastructure is not about what and how, it's really about when, right? Attacks are going to happen on IoT. It's not happening because in production there are very few IoT systems, and those which are out there, you know, the city of Houston, and they were attacked. And all IoT would be under attack because it is an extremely either commercially, you know, powerful way of getting into infrastructure and disrupting it. It is also a huge target for nation states, right? Think about critical infrastructure. Think about your smart grids. So attacks are going to happen. These are going to emerge in the next couple of years. And if we are not ready for it, and if we are not thinking in terms of end-to-end security for IoT, I don't think it would be secure. So how do we deal with that now? And imagine now, this is now an ecosystem play. right? There is a silicon manufacturer somewhere. There is an operating system manufacturer or designer or developer somewhere. They bring that onto the device. There is a device manufacturer who puts it all together. Then there is this person who takes that device and deploys it somewhere. There is somebody who builds the whole solution on the device, the connectivity, and in the cloud. And then there is this whole operation. And then in that mix is the cloud provider, us. Right? So all of us are involved in its end-to-end operation. And mind you, this is a scaled operation. Right? This is not 2 devices or 20 devices. This is millions of devices, hopefully, spread around the world, which are connected over this IoT network. So the problem becomes more complex here. Now what we do is, and I just described some of these roles. I like to call them roles. These are people who do different things in the IoT infrastructure, manufacturers, integrators, IoT solution developers, IoT cloud developers, providers like us, IoT operators which run the day-to-day functions of the device. They're all involved in this. So the first thing we did was we put out a bunch of best practices for each of these roles. Right? The URL is over there. Sorry, it might be a little too smallish. You can read that. So if you go to this URL, you will find best practices for each of these roles. Now, mind you, some of the roles might be together, some might be different, but within that role, we have tried to stipulate some best practices. For example, if you are a device manufacturer, a silicon manufacturer, what is your secure storage story? How are you storing it? Right? And also the goal of these best practices is to give the people, our customers who want to deploy IoT, an understanding of what all is involved in securing an IoT solution. Right? There will be many people coming to them and saying, oh, IoT is all secure and we can deploy. They rather first read all of these best practices of what all needs to happen before IoT is really secure. Right? So I would encourage you to go in and look at these best practices. If you are one of these, or if you work with one of these are something that is important to understand. Now the other thing that we have done, let me check on time. Okay. The other thing that we have done is we have taken the stride model, which has been used by IT for a while now. Right? This is really a threat modeling mechanism, a threat modeling taxonomy. And then linked to that is a tool which allows you to model threats in an architecture. This is more design time. When you're designing your architecture, you try to look at that. We have tried taking stride, and we have applied it to IoT scenarios. Right? So the goal here is, again, giving IoT people who are ready to deploy IoT, people who are developing apps for IoT, people who are looking at it end-to-end, or even only the device, giving them this tool which allows them to look at threats so that they know what they're getting into, so that they can mitigate it appropriately. Right? So for those who are not familiar with the stride model, it's really a taxonomy of different threats. For example, spoofing is one threat to an infrastructure. Where somebody could take in an identity or a credential and could use it for malicious purposes. And so what you do is you take, there's a tool, free tool which you can actually download, allows you to model your architecture and define certain places where you are going between trust boundaries. So from the local machine to the cloud, there's a trust boundary there, and to evaluate what all attacks are possible on that trust boundary. Right? And then it would give you a few suggestions of how to mitigate those threats. And what we have done is we have tried to apply this to an IoT scenario. Right? Again, a URL at the bottom over here, which takes you to the threat modeling tools that we use for IoT. We took an example and we modeled it with this tool. And so we have put all of it up there, again, so that you can use this tool for your threat modeling. Okay, so I think that brings us almost towards the end of our introduction to IoT security. The URL up there would take you to a bunch of resources we have there. We have been thinking a lot about threat modeling, we have been thinking about best practices, we have been thinking about how do you think about security all up, end to end. All of those are documented as white papers in there. We also have a blog which we try to keep updated with new things happening on the product as well as in the IoT world. And so this is really how you stay connected with what we are doing in security. That brings me to the end, and I think we have about 5 minutes, and I'll welcome any questions that you might have. Please, and it would be, if you can come to that microphone.
Yeah, it's a question loosely related to security, but in directories of days past, you had standard schemas for people, like inet.org person, similar, computer schemas. Is there a industry standard for inet.org thing, or how are you defining what attributes are associated with these things, and then making sure that across multiple suppliers, that work isn't just left to someone that's trying to build a system,
right?
To have to define all that stuff.
Thank you, thank you. So the question is, how do you define the schema for identity of a device, and how do we standardize that? So as part of all of this work, we are very actively working with standard bodies. And one of the work that we have taken to standard bodies is exactly that. How do you embed a device identity, and what is a standard schema for that device identity, which you embed in silicon? And it's immutable, so there is cryptography on top of it, and so you can't really discover that device identity once it is burnt in silicon, but you can always get to it through a hash. And so we are driving those standards. To answer your question, there is not many standards which actually deal with that. We probably are one of the few people who are driving those standards today. Any other question? Please.
Hi, this is more about the IoT gateways. And so usually, I guess, what kind of operating systems would you recommend for the IoT gateways, and what would be the practices to keep it secure? Because it's essentially a small server that would connect to it.
Right. So the question is, how do you secure IoT gateways? So before I answer that question, IoT gateways are these devices which are more high powered, and they essentially are a medium for other devices to connect to the cloud. So for example, other devices, your sensors and all, might not be talking IP, or you may be talking IP, but you do not want them to connect directly to the network. And so you put a gateway in the middle, which might be just an aggregation for protocols and for data, and then that gateway connects to the cloud. By the way, we have an open source gateway that for Linux and for Windows that is out there on GitHub. We also have a partnership with Eclipse, the Eclipse Foundation, for their, I believe, Kura gateway. So, and that would have an IoT connectivity to Azure. So we are working on those, and yes, addressing those gateways and ensuring that you have the means to authorize what is possible and to identify those devices is important. We have actually implemented that gateway. Again, go to GitHub, look for Azure IoT Gateway, and you have a reference implementation right over there. Any other questions? Well, thank you very much for your time. Thanks a lot.